Welcome to the lecture on weldability of alloy steels. So, in this lecture we are going to have the discussion about the welding characteristics and weldability aspects of the alloy steels, and in that also we will talk about the low alloy steels also. So, first we will talk about the one of the very important variety of low alloy steel, that is high strength low alloy steel. So, although alloy steel are categorized as low alloy and then once you have the alloy content more than certain specified percentage, then only it is alloy steel. So, in the case of this is a typical material which is very much used in specific areas. So, so that is high strength low alloy steels. So, these steels are basically designed to provide better mechanical properties and sometimes better resistance to atmospheric corrosion than the conventional carbon steels. So, high strength low alloy steels are very much used in the automobile applications and even in other transportation industries or so. So, the weldability is similar to the mild steel, however, they often require preheat and also control of hydrogen in the welding process. So, basically in this case you require the preheat and also the hydrogen control is very important. So, the preheat and interpass temperature, that will be depending upon the carbon equivalent value of the steel, and the carbon equivalent value will be depending upon the different alloying elements which are used in the steel. And when we are using the two different HSLA steels together, in that case the higher of the two preheat temperatures for the two steels which are to be joined, that has to be selected. Then in these cases the base metal on each side of the joint, they should be preheated to a temperature over the distance equal to section thickness or 80 mm, whichever is larger. So, in these cases what we do normally is we take care that on each side of the joint a minimum of 80 millimeter or the equal to the section thickness, that much must be preheated. Commonly used welding processes are shielded metal arc welding, gas metal arc welding, flux core arc welding, and also the submerged arc welding. So, these are the commonly used methods which are preferred for these kind of materials. So, and also low hydrogen process should be employed in all the cases to have the better results. Now, they can be welded using the ESW process, that is electroslag welding. In that cases we do not require the preheating because of the high heat input characteristic of the ESW process. So, this is that way you will have certainly some difference as compared to the mild steel of these processes. Now, more importantly, when we talk about the alloy steels, then we talk about the stainless steels, and as we know that these type of steels as they are corrosion resistant, you are typically adding certain alloying element which tend to increase the corrosion resistance of the material, and among the elements which are to be added is the chromium as the most important alloying element, and at least 11.5% of chromium is added to get the corrosion resistant or stainless steels. So, they are also known as the corrosion resistant steels. So, basically this is this layer of chromium oxide. So, that basically acts as a barrier to the further oxidation, rust or corrosion. So, that is why they are known as the corrosion resistant steels. So, since they cannot be stained easily, so that is why they are also known as stainless steels, because if you provide the stain, it will not be possible on these they will not look, you cannot see them. So, that way that is why they are known as the stainless steels. Now, if you talk about these stainless steels, they are broadly divided into different types, and these types are like you have austenitic stainless steel, you have ferritic stainless steel, and you have Martensitic stainless steel. So, that way accordingly you have broadly these 3 categories of the stainless steel which are there. Now, coming to the austenitic stainless steel. So, if you try to see the properties of these steels. So, now first of all these steels have the austenitic structure at the room temperature. That is why they are known as the austenitic stainless steel. Now, they exhibit the highest corrosion resistance among all the ferritic or you have the Martensitic or among these 3 types of stainless steels, they have the highest corrosion resistance. They get good the best strength and also the scale resistance at high temperature. So, as compared to other 2 steels, they retain the ductility even at very low temperature, even at the absolute zero temperature also they are ductile. So, that is very much used has to be, this property has to be used in many applications when you are using the material in those kind of environment. Then they are also non-magnetic. So, that is again it is their property. So, this is about the austenitic stainless steel. Then if you if you come to talk about the other kind of steels. So, normally if you look at the austenitic stainless steel. So, we discussed about these properties, and normally you have carbon as 0.03 to 0.25%. You have manganese from 2 to 10%. You have silicon is 1 to 2%. Chromium is here from 16 to 26%. So, that is quite large value in this austenitic stainless steel here. Then you have nickel as 3.5 to maybe 22% or so. So, that basically is making it really austenitic. So, that nickel alloying element, and then you have phosphorus and sulfur, which is normally there used in the aircraft industries, and you have the heat exchangers, food processing kettles and all that. Milk cans, all these are made by these austenitic stainless steel. Similarly, if you go to the ferritic stainless steel. So, as the name indicates they are their macrostructure is primarily ferritic. So, that is why they are known as the ferritic stainless steel, and they have normally low carbon to chromium ratio. So, that is the property of these materials of these kind of steels. So, basically they will be eliminating the effect of these thermal transformation, and also it will prevent the transformation by or the hardening by heat treatment. So, they have, since because of this low C to Cr ratio, they will not be very much responding to the heat treatment processes. These steels are basically magnetic and have good ductility. So, that is the again property of these ferritic stainless steels, and they do not work harden to the appreciable degree. Say, so do not work harden to appreciable degree. Now, they are ferritic stainless steels, they are more corrosion resistant than the Martensitic stainless steel. So, that is the property, and they have good softness and ductility and corrosion resistance in the annealed condition. So, normally if you come to the composition of the ferritic stainless steel, normally you have carbon is 0.08 to 0.2%, then you have silicon as 1%, manganese as 1 to 1.5%, and chromium is about 11 to 27%. So, that is carbon, if you look at it, is in the smaller carbon to chromium ratio is actually is the smaller one in this case, and they are used in the lining for the petroleum industries. You have it is used in the heating elements for the furnaces. So, that way you have its use in the different areas. Then if you come to the Martensitic stainless steel. So, the Martensitic stainless steel, again as the name indicates, it will be having the Martensitic structure, macrostructure. So, that is why they are known as the Martensitic stainless steel. Then they have the high carbon to chromium ratio. So, they are the hardenable type of material, and they can be hardened by the heat treatment process because of the high carbon to chromium ratio. Then they are magnetic in the all conditions, and they have the best thermal conductivity among the all. So, then they can be cold worked without much difficulty. Then they can be have good finishing, they can have good toughness, all these properties are there with these Martensitic stainless steels. And if you talk about the composition, so carbon is 0.15 to 1.2%. Then you have the silicon as 1%, you have manganese again as 1%, and chromium is from 11.5 to maybe 18%. So, this way quite high value of the carbon to chrome, see 0.15 to 1.2. So, that is there. So, they are used in pumps and valve parts, then used for turbine buckets. So, these are the special uses of these kind of different type of stainless steels. So, if you come to this slide, so you have so now we are coming to the austenitic stainless steel. Now, as compared to carbon steel, austenitic stainless steel has more electrical resistance. So, basically the electrical resistance is 6 times more than the carbon steel. Similarly, it has the less melting point than the carbon steel. It is normally close to 100 degrees C lower or 90 to 100 degrees C lower than the conventional carbon steel. So, it has less melting point. It has lower thermal conductivity, about 50% low value of the thermal conductivity is there, but it has a very high thermal expansion, about 50% higher thermal expansion is there in the case of austenitic stainless steel as compared to the conventional carbon steel. Now, because of these properties, what is happening is if you take these 3 properties like the electrical resistance, which is quite high, so you will have more heating possible if you use the electrical means to heat. Similarly, less melting point, so certainly you again require the less heat, and then low thermal conductivity, so heat dissipation will be less. So, all these 3 points, they will they will give you a good condition for the lower welding current requirement. So, in the case of austenitic stainless steel. Then the higher thermal expansion, if you look at this point, so that is certainly a disadvantage, and because of the higher thermal expansion, it will be it will have the tendency of warpage and distortion, and it will also have the higher chances of weld cracking under the restraint conditions. So, because once you have the, because of the temperature variation, you have the more expansion or contraction going on. In those cases, the chances of cracking, weld cracking under that restraints is higher. So, the allowances are to be made for the increased shrinkage in the thick sections, because you have quite a large thermal expansion. So, especially in the thick section, you will have to have the precautions for the by taking the allowances. So, that basically will diminish the probability of having defects related to these large expansion in the case of welding. So, so one is so the points which are to be taken into consideration at that point will be like you have used the skip welding technique, that is what we have discussed earlier. You can use the back step procedure. So, you can have the welding in the back step directions. Then you use the use of tack welds. So, you can have the use of heavy tack welds. So, you can use the heavy and frequent tack welds, positioning of sections also, so that the contraction which is there, that puts them into alignment. So, all these are the ways basically to account for or to take care of the increased shrinkage probabilities in thicker sections. When they are heated in the temperature range of say 427 to 870 degrees C, or in fact cooled even through that range, in that case the carbon is precipitated from the solid solution at the grain boundaries. So, that is one thing which is important, because the carbon which is precipitated. So, you will have the depletion also, you have the chromium carbide formation, and then accordingly the chromium which is primarily used for the formation of chromium oxide, which will give you the stainless properties. So, in those cases carbon is precipitated from the solid solution at grain boundaries, and there it will be uniting intergranularly with the chromium again to form the chromium rich carbide. So, basically you will have the formation of chromium rich carbide instead of having chromium oxide. So, formation of these carbides effectively eliminates much of the chromium from the adjacent area. So, that is what it normally does. If you have the formation of chromium carbide, you will have the depletion of chromium oxide. So, lowering this and once you have the depletion of the chromium oxide, then it will you will have the lower lowering of the value of the corrosion resistance, and also you have the susceptibility towards the localized intergranular attack, that will be depending upon the time and the temperature of the exposure. So, that is what normally happens when you have the susceptibility, when you have you are passing through that temperature range. So, in those cases this is likely to happen, and it will also be depending upon the time and temperature of the exposure. So, what we do is normally when what we do is normally for avoiding these carbide precipitation during the welding of austenitic stainless steel, we can have certain ways we can adopt to have the control on the carbide precipitation. So, first is that you reduce this time during this temperature range. So, that temperature range which is there, like 427 to the 870 degree centigrade temperature range is there. So, in that time and in that temperature range, you have to reduce that time. So, you can have the lower heat input into that, or maybe that you can go for rapid cooling through that temperature range. So, basically that will avoid the formation of these chromium carbide. Then you have the selection of the stainless steel with lower carbon content. So, because that if the amount of carbon will be lower, so the chances of chromium carbide formation will be smaller. So, that is another way that you will have the control on the carbide precipitation. Then you can have the addition of different elements also which can control the carbide formation, and certainly by adding those elements which have very strong carbide forming tendency. So, that will help. So, for that we take different type of elements which are very strong carbide forming elements, like titanium is there, columbium is there. So, all these elements we can use tantalum. So, these are strong carbide forming elements. So, we use them so that instead of chromium carbide you have the formation of those carbides, and you have still the availability of chromium to have the formation of chromium oxide. So, that is another way to have the avoidance of the carbide precipitation. And then you can have even the appropriate heat treatment also process you can use which will reduce the susceptibility to to have the intergranular corrosion. So, because of that so what will happen, that this there will be complete solution of these carbides, and then you can have these heat treatments. So, that will be kind of annealing heat treatment, where you can have the maximum corrosion resistance. So, for that what is done is, normally you are heating the weldment between 1040 to 1120 degrees centigrade normally. So, you go and heat between that temperature, and you have to have the adequate holding time, and maybe 1 hour for every 25 mm of section thickness. So, and you cannot have less than half an hour of holding. So, that is your adequate holding time that should be there. Then you go for the rapid cooling through this temperature range of 925 to 538 degrees centigrade. So, in that you are going for the rapid cooling to hold its carbon in the solution, and then you are also cooling in the air or water depending on the thickness. So, when your thickness is less, so in that case you can cool in the air, and if your thickness is more than that, in that case it can be plunged into water or spray cooled. So, this way you will have the control on the carbide precipitation during the welding of the austenitic stainless steels. Apart from that you have many other processes by which you can do the welding of these austenitic stainless steels. You have the techniques like oxyacetylene welding is there. You can go for arc welding. All the type of arc welding can be used satisfactorily for this purpose. Then you can use for the resistance welding, and all other welding processes can be used satisfactorily for this material. Now, we will come to the weldability aspects of the ferritic and martensitic stainless steels. So, as we know that you have we talked about these 3 kinds of steels, and welding characteristic of the ferritic and martensitic steels are different from the carbon steels and also from the austenitic stainless steels because of the certain factors, like you have there is seen to be the decrease in the UTS, ultimate tensile strength, more rapidly with the temperature. Then you have the pronounced grain growth when your temperature is going ahead of 900 degree, in excess of 900 degree centigrade. Then melting point is also below the carbon steel, and expansion coefficient of these steels they are same as the carbon steel. So, here what you see that in those cases for austenitic stainless steel the expansion coefficient is quite high, whereas for the ferritic and martensitic stainless steel you have the expansion coefficient which is same as that of the carbon steel. So, and then if you talk about the thermal conductivity of these steels, so they are less than half of the carbon steel. So, that way if you talk about these so electrical resistance is also more than that of carbon steel. So, basically what is happening that now because of these effects what you see if you talk about the effect of these points. So, in the case of ferritic and martensitic stainless steels, what you see is that your less heat input is there because the same characteristic as that of austenitic stainless steel. So, less heat input is required. Then preheating and post weld heat treatment, that is very much desirable. So, post heating is desirable. So, because there is also grain growth going on, so those things are to be taken care of, and distortion condition is not so severe. So, because in this case it is not as high as that of the austenitic stainless steel. So, these are the traits of these steels. Now, coming to the welding of the ferritic stainless steel, in general these steels are less weldable than the austenitic stainless steels. When they are heated above 954 degrees centigrade during welding, then actually growth growth is very much a matter of concern in these kind of materials. So, here the growth of ferrite grains is promoted, and what we see is that this larger grain size of the ferrite along with a small amount of martensite also that is formed because of the cooling conditions. So, that will induce brittleness, and then there will be lack in toughness and ductility at the room temperature in the weld is observed. So, that is one thing which is normally observed in the case of these kind of steel. So, what we do is for minimizing this grain growth, what we do is that we keep this preheat and the interpass temperature which is normally used, we try to keep that as low as possible. So, that is what we do. So, we normally what we do is grain coarsening can be controlled by avoiding this slow cooling from the welding temperature. We have the intergranular precipitation if cooled too rapidly, that is there is if you do the cooling too rapidly, then there may be intergranular precipitation. So, heat treatment from 700 to 820 degrees C. So, from here you must go for moderate cooling for avoiding that intergranular precipitation. Then preheating at about 150 to 210 degrees centigrade is suggested, and for the post weld heat treatment temperature is generally kept below the 843 degrees centigrade to prevent these grain growth and the austenite formation. So, beyond the heat affected zone. So, that these kind of precautions are taken in the case of the ferritic stainless steels. If you come to the martensitic stainless steels which have the martensitic type of structure at room temperature. So, here the problem is that when you are heating these steels, so austenite will form, and if you are going for further cooling, in that case your because of the austenite transforming to martensite, you will have transformation induced stresses formed. So, that is one aspect because of which they and also it has very low value of thermal conductivity. So, you will have the chance of cracking, and especially when you have the brittle macrostructure which is formed because of the rapid cooling rate. So, this is possible normally in these kind of steels. So, what we do is for reducing these transformational stresses and to increase the toughness and ductility, we preheat also, and also we go for the post heat of these materials. So, most commonly what we do is you are preheating about 150 to about 260 degrees centigrade. So, that is normally the preheating, and for post weld heating you go from the about 750 degrees centigrade to that temperature, and then holding there for about 1 hour of per 25 mm section thickness, and then further you are cooling slowly at the rate of 10 degrees C per hour. So, that way you are cooling up to close to 600 degrees centigrade, and then you are cooling in the air. So, that kind of post weld heat treatment you are doing in these cases. So, this is roughly the welding characteristic of these materials, and you can have the use of different processes like TIG, MIG, you have the SMAW processes are used, you can use the submerged arc, you can use the resistance welding processes for these steels. So, that is about the weldability aspect of the different type of stainless steels. Also we talk about the HSLA steels. Thank you very much.